Good. So I will talk about multi-agent orchestration. We're working on some AI products that we want to release to our customers so they can get some extra benefit from all of the data that we have available without having to be an expert in that field. Let's start with what defines an agent. How I see it at least is that an agent is some kind of a generative model, an LLM most likely, that has some kind of autonomy so that it can independently choose to do things. Those things could be to gather data or make actions. The world's first autonomy choose what it needs to look at to answer the question and to do something about it afterwards. And one of the ways that it makes sense to do that is to implement tools. When you send a request, you send some kind of prompts and messages. A system prompt, predefined stuff, and then you have the question from the user or some other task. Then you can, for most models and functions or tools, at the most low level, these are just JSON schemas. So they are defining some input parameters with some descriptions for what this tool does, what could you expect to get back from this tool, and which parameters need to execute the tool. Then what the model will think based on the user's question, do I need a tool to answer this question? So that could be, is this something that I already know based on the pre-trained data? If it is, we'll just generate a text response and send it back to the user. If it is something where I need to get current information like weather, do I have in this tool definition status schema? Is there something I can use to get the weather? There is. Cool. What do I need for that? I need the location to get the weather. If it has the location, it could say, I actually need to ask the user, or if it has the location, it will call the tool, it will send back a message with no content, then wait for some code to pick up on that message, execute the tool, get the data, send it back as a new message, and read that message and return something to the user. So there's a cycle going on behind the scenes for most users in a chat UI to gather this information. That is what a tool is. And that is one of the ways you can give it autonomy, because now we can choose when it needs to get different information. Let's jump to multiple agents. And why do you need multiple agents? The answer is you probably do not, because many tasks can be done by one agent with tools that's prompted well and described it. It makes sense if you find out that one agent simply doesn't understand this amount of tools you have for the different kinds of tools if they are close to each other. We have some tools about data. We have 3 different categories of data, and they actually look a lot alike, the 3 different categories. And if we have one agent that has access to all of these tools, sometimes when the user is not very precise in its question, it will think they are talking about one of the other types of tools. So they will call the wrong tool and say, this is the right number for you, but actually it was the wrong data source. It could also be that some of the tasks that you need as part of a workflow can be done by a smaller model that will not cost you a lot of money. Therefore, you should probably consider if it was cheaper for you to use a smaller model for that part of the flow. And in trading, we have a special case where we want to extend our developers, third-party developers can code with agents. So we want to have some kind of experience where the users can enable and disable different agents, communicate with them and get insights. It makes sense for us to have multiple agents and make a framework where it's easy to plug in other agents or data sources. How can you implement it? It depends on what you're trying to build, so just to show how it works. In many cases, you could probably do the 2 if statements and some calls and do something, and you get them response back, do something else. Or you can look at the frameworks. And here, just a few of the frameworks. There's also the agent SDK from OpenAI that just came out last week. But I've been looking at the Mastra. It's a JavaScript framework for it. There's a Python equivalent that looks a lot like Mastra, but just in Python. Then there's a CloudFlare agent that you like CloudFlare if you want to build on their infrastructure. And there is a LangGraph, which is built on LangChain, and which is a Python and JavaScript version with a lot of tuning around it. One note is that the LangGraph is very big. And when we look at Agnew, they claim at least that they use 50 times less compute to do the same things. So maybe consider one of the smaller things if you are looking at building. Let's go into Mastra quickly to show how that works. In Mastra, you have an index file. You create a new Mastra instance. You have one Mastra instance that's basically your server that you create, and then you can define workflows. You can define agents that is for specific agents that you can then chat with, record contact, and you can use your agents inside of your workflows. Let's go and look at that. Agent, simple, weather agent. So an agent in their case is a name. Then the instructions, like the system prompt, and then you define which model you want to use. They are built on top of the cells AI. You can exchange models from different providers. You can use local models from Aalborg or whatever you want. And then you also define the tools that it has access to. In this case, we have the weather tool and the datetime tool. Let's look at the smallest one for the code. The engineered datetime tool, where it can ask for the date and the time in a lot of different formats. And that's actually a really important thing. Whenever you want to have an agent that have access to some external source to do stuff, you always want to give it some kind of information about what is the current day and time. You don't need a tool for that. You can just put it in the system. That's fine. Because otherwise it will always go back to whenever the model was trained on OpenAI September 2023 or something like that. And now we're defining a workflow. In a workflow, we define steps. In this case, each of these steps are basically executing and calling the agent corresponding to the steps. So one step equals one agent. This is just one coded flow. We're creating a workflow. First, we have a research step. Then we have a copywriter step. An agent will search the web, crawl some pages, and then start getting information on that topic. The next agent will take that information and turn it into some kind of copyright, like a blog post. Then we have an editor that will start making that blog post pretty and following the format of that blog, so the way you want it to be. Then we have side by side a social media step where you can start making posts for all of your different social media platforms. And in the end, you'll have a summary. The idea here was to present the summary within May. After these 3 steps done, we'll have a final assembly step. We could also post to social media on the blog and send out the email. What I find really nice with Mastra is that when you run the Mastra command, they build a full development environment for everyone with the local host, where you can see all the agents that are available, all the tools that are available. You can even test out the tools by calling them directly inside of this UI to see if you get the expected output. And you can go to an agent and chat directly inside of this UI as well. You will also be able to look at the traces for the agent and there's built-in evaluations. So you can look at things doing what you wanted to do based on the input. They also have a lot of predefined evaluations. Basically, it's a profanity. Then they look at it and give it a score from 0 to 1. And then workloads. Here we have my multi-agent workflow. And you get a nice graph. That's what I wrote. You put it down there. So here you can see what I talked about in the code before. Now we're starting the workflow up. So we should hopefully see the research step running in a bit. Here you get which step is running, the output so far. And you get you see how we are going to the copyright step. While that is running, let's look at what. So how now we have a UI to testing it, or how do I actually implement it into my applications? And what you get out of the Mastra instance is a full all of these scripts. For the tool list, the tools one right there for the workflow set of the endpoints. There is also a bunch from memory and other features that I haven't gone into yet. And there's also the invites for the agents. You can get a list of the agents that exist in this instance and so on, and you can also call them. And for all of the agents, there will be a generate step. That is when you send a request once, wait a long time, and then you get the response. But there's a stream where you stream back the flow. So like you see in ChatGPT, a few words at a time. You can execute a flow, resume it, and start when you've done any of those, you can roll back the time to get the data. And that's one of the things I find a bit lacking, because if I want to build a multi-agent setup that has some kind of chat functionality, I don't want to do the polling and getting a full step at a time. I would like to see the steps as they go. But if I need to do evaluation, well, I couldn't do that because it's hard to evaluate until you have final message. So the research step and the copyright step is completed. Okay, so we don't see it in the top, but actually it did run it. We have the summaries on the summary step. We have the social media post. So there's a blue sky post, and we have the written copy. So now we have all the things, and you could do whatever you need to do with that. And I think that's it for my short presentation.